When you are explaining Mars and Moon, that sounds like a sci-fi movie. I'm watching Star Wars or something like that.
Yeah, that's
Massive volcanic eruptions, canyons, 1,000 kilometers wide, monumental.
on the moon. The surface is covered in craters from ancient asteroid impacts. Solar radiation bombards regolith with plasma. The dark plains called Maria, formed by lava flows nearly 3.5 billion years ago, and underground lava tubes that are fascinating for me personally, and it could be future habitats for human. Moon dust is dangerous because it's incredibly tiny. It's fine, like 10, 20 micrometers, and it's really razor sharp. Unlike Earth's dust, which gets smoothed by wind and water process, Moon's lack of atmosphere and weathering conditions, so it leaves these grains jagged like tiny shards of glass. Astronauts like those on Apollo 17 reported dust sticking to their suits and wearing clogging zippers and wearing down gear. And studies of returned samples showed how abrasive it is. You asked me about what we can do about it. It's not just a trouble. It's also our main and only resource on the moon. And my work involves exploring ways to use regolith for in situ resource utilization. For example, researchers testing how to mix it with binders to create lunar concrete for building habitats with 3D printers. Regolith also contains a really big amount of oxygen locked in minerals like almanite, which we could extract for breathing and for fuel.
And we're like, hi, Rina.
Hi, Maria. Yeah.
Thank you for being here.
Thank you for inviting me here as well.
Could you please shortly introduce yourself for our viewers and listeners?
I'm Rina Faber. I'm planetary scientist, and for now, I do my first startup. I'm a CEO of a lunar company, or LunCo, and also I'm a multidisciplinary specialist in planetary science and in risk management that's correlate with topics like space medicine.
Very cool. So I've never had a specialist in space medicine here on my podcast yet, and I'm sure that we will dive deeper in this topic today.
Yeah, let's try.
But first, I'd love to ask you, when did you first become interested in space? Did you want to be an astronaut when you were a child?
When did I first get into space? Probably when I was a kid, around 7. I was obsessed with anime like Sailor Moon and
Yay!
Fifth Element. Those stories had these amazing female characters tied to space, and they just blew my mind at the time. I remember watching the news on Cosmonaut 6 Day on 12th of April when I was 12, and they showed the ISS. I noticed there were no women, and I thought that's such a shame that this type of work, it's not a job for women. And also, ISS looks so dull inside. I dream about making it look cool. And that's because my parents are designers. So for a long time, I thought I'd follow in their footsteps. But my grandma, who's super important to me, she wanted me to be a doctor. But in the end, I didn't become a designer, doctor, or even an aerospace engineer, but something in between all of these topics. Yeah. So when I was a teenager, I was super intense about meaning of life and choosing a career. I felt like everyone should figure out big questions like how the universe works or what infinity really means. And that's what pulled me towards space. My first degree is in astrophysics. I only seriously thought about becoming an astronaut when I was 25, but my eyesight was a deal breaker for me. So I figured there are other ways to get into space. At that time, I even applied to Mars One project. Now, with all the commercial space flight popping up, I'm sure I'll get to orbit someday. And my goal is to do it before I'm 50. So it feels doable right now. Just a matter of time and money. I say that.
Is there actually an age limit for astronauts? So do you need to do that before 50, and otherwise they will take you?
We know many astronauts that are Petit is like 70 years old, and he's just back to Earth. So it's about the time you need to get prepared for the space flight. So 35, it's the right time. So it's not the end, it's just the beginning.
Great to hear that space is so inclusive that it's never too late.
Yeah.
So, and you found your way to get into space. You've been studying for 20 years.
I've been studied a lot.
Oh, yes, absolutely. So I would love you to share your knowledge with us. You've been studying lunar and Martian surfaces for space missions. And I'm absolutely sure that not many people actually know what the surface of Mars or Moon looks like. Tell us about that.
Wow, it's a big topic. So, as a planetary scientist, it's my second master's. So, I dive into the surface of the Moon and Mars to also guide missions, and these worlds tell incredible stories about our solar system. So, on the Moon, the surface is covered in craters from ancient asteroid impacts, but even today, every minute, thousands of micrometeorites, tiny rocks about millimeter wide, they slam into Moon, shaking rocks into a dusty layer called regolith. Solar radiation bombards this regolith with plasma, altering its chemicals and implanting ions in creating tiny glass beds. And this is important stuff for space exploration. This constant bombardment with no atmosphere to block it preserves a record going back 4 billion years ago, and the dark plains called Maria, formed by lava flows nearly 3.5 billion years ago, and it's covered like 50% of the surface of the Moon, and mostly on the near side of the Moon. So these basaltic plains, they come from massive volcanic eruptions in the past. So Moon has molten past and underground lava tubes that are fascinating for me personally, and it could be future habitats for human. And the far side, with fewer Maria and more craters, it's reflect a thicker crust shaped by early impacts, and it's uneven heating nearest discovery. So Mars, by contrast, and Mars is my major study, not the Moon. So it's a red, rocky, irony world that's shaped by iron oxide, and it boasts Olympus Mons, a 22-kilometer volcano, and it's the highest and biggest volcano in the solar system. And the cool thing, like Valles Marineris, it's a canyon that are 4,000 kilometers long, and it's also 10 deep. So it's really cool stuff. It's not so easy to imagine the thing on Earth, and it's It has also dry riverbeds and deltas point to liquid water and possibly oceans in the past. And I study minerals like clays, sulfides to reconstruct Mars paleoclimate. It's research about how warm and wet it was back then. And these minerals, particularly clays, they formed in water and it's a clues to ancient environments. And unlike Earth, Mars lack active weathering conditions from wind or water. So its surface is like a time capsule, letting us to trace this history. So basically my work focuses on analyzing this data from lunar and Martian rovers and orbiters and decode surface components and composition, tackling these big questions.
Super fascinating when you are explaining Mars and Moon. That sounds like a sci-fi movie. I'm watching Star Wars or something like that.
Yeah,
Massive volcanic eruptions, canyons, 1,000 kilometers wide, monumental.
yeah, but it's how we don't have such structures on Earth. Yeah, that's amazing.
Yeah, but also you said lava tubes. So is it possible that in the future, when humanity will establish a base on the moon, it won't be on the surface of the moon, but underground?
When we figure out the technology to make our presence safe and sustainable on the moon, it definitely will happen, but not in the first round. In the first decades of moon exploration by humans, it will be like moon bases that we see in all futuristic films, cinema, Netflix, and so on. But in the distant future, because lava tubes are distant to the places where you can have amount of water and other valuable volatiles that you need for survive on the moon.
I know that there is very interesting research that is focused on how to use moon regolith and produce through bioengineering, chemistry, whatever, a lot of essential stuff to actually survive on the moon, like oxygen. I'm not sure about water, but a lot of like building materials and everything.
Yeah. It's a really fascinating research right now in the field. So everyone on it, it's like a gold rush, but moon rush with all that. I hope we figure out all this really quickly, and it will help us to navigate our presence on the moon.
Yeah, and you're also building an analog mission lab to simulate the lunar environment, since it already seems that Moon Regolith is the main hero of today's episode. So there is moon dust. Yeah, moon dust. It interests me a lot. I've read that moon dust is dangerous for humans. Why?
How to handle this in our analog mission lab that's I currently part of, and we're building a setup to mimic the moon surface, and it's pretty exciting for me. And we simulate the lunar environment to test how habitats and cosmonauts would handle it. The star of the show is our massive test bed, so-called test bed area. It's like a giant sandbox where we can run rovers and mock habitats, and we fill it with lunar regolith simulant. And it's engineered to match the real moon's dust. It's a fine abrasive, really abrasive, and packed with minerals like plaquer glass and bits of volcanic glass. So this regolith mimics how the real stuff sticks to gear or clocks mechanisms, and letting us study wear and tear without needing the real lunar samples that are really rare on the Earth. So it's like less than 40 kilograms of it on Earth. So these tests help us design tougher equipment and plan future missions, the safety of manned missions, especially in my lab. So we have newly open big laboratory for all kind of moon research in Köln, in Germany. It's a lunar facility. It's near Astronaut Space Center. And my laboratory is specialized only on the topic that correlates with medicine, biology, effects, and so on. So lunar regolith or moon dust is a real challenge for human, but it's full of potential. Moon dust is dangerous because it's incredibly tiny. It's fine, like 10, 20 micrometers, and it's really razor sharp.
So it will cut you if you will breathe it.
Yeah, unlike Earth dust, which gets smoothed by wind and water process, Moon's lack of atmosphere and weathering conditions, so it leaves these grains jagged like tiny shards of glass. So they can not only scratch the equipment, but lodge in astronauts' lungs, causing not just irritation, but long-term health risks similar to silica dust exposure. And we know this from the Apollo missions. Astronauts like those on Apollo 17 reported dust sticking to their suits and wearing clogging zippers and wearing down gear, and someone, I don't remember who, had allergic like reactions after inhaling traces of lunar dust inside lunar module. So dust chemical composition is rich in silicates, iron, and it's react with solar radiation, making it electrostatically charged, and that allows it to clinch to everything. And studies of returned samples showed how abrasive it is. You asked me about what we can do about it. It's not just a trouble, it's also our main and only one resource on the moon. And my work involves exploring ways to use regolith for in situ resource utilization. It's a really fancy topic right now in the field. So, for example, researchers testing how to mix it with binders to create lunar concrete for building habitats, for example, with 3D printers. And it could save the cost of launching materials from Earth. Of course, regolith also contains a really big amount of oxygen locked in minerals like almanite, which we could extract for breathing and for fuel. And some experiments even aim to pull out metals like iron for constructions. So we need to study this, and we can study this in the dust conditions in labs like our analog setup. And we will definitely learning how to protect astronauts and cosmonauts and turn this big problem into a tool for the future.
So the moon dust is not only an enemy, it's also your best friend.
Yeah, it's the biggest ally, our ally, because we cannot survive without resources on the moon, of course. We cannot always supply us with something from Earth. It's not sustainable.
Yeah, that's why I was super fascinated. I had on this podcast a lady who engineers microbes for Mars. Anyway, I mean, for Moon would be also nice. Mars probably even more hostile towards life organisms. But she mentioned something that really stuck with me. She said these closed biological systems made for space, because in space you cannot cheat. On Earth, you have a lot of stuff, a lot of resources available to you. But on the moon, on Mars, you are limited to what you can produce. So having these bioengineering systems can be crucial for survival on these planets.
Yeah, it is. It's really so. Studying that, we also can understand how was their life on Mars, for example. It didn't happen for Moon. of course, but for Mars, it could happen in the past. So if we study this topic, we can make retro research into how it could be in the past.
So you are also actively studying astronaut longevity. Does space make us age slower or faster?
Yeah, that's another part of my research because I'm working in space medicine. So I just fascinating about everything. So that's how I end up in many in many research. So longevity is one of them. I'm a part of team that's studying how space affects cosmonaut longevity, especially for long missions like half a year. Space can accelerate aging in some ways and slower in others. We piecing together the puzzle using data from ISS mainly because what do we have? Lab experiments, and for now it's also machine learning to spot long-term patterns from all the data that we have. So space hits the body hard, and cosmic radiation like galactic cosmic rays and solar particles, they bombard human astronauts with doses far higher than on Earth, and this damage our DNA, raising cancer risks over time. But it's a long duration effects, and microgravity, on the other hand, is another issue, and it's a short time effect. And astronauts lose 1 or 2% of bone density per month in space, and it's a big issue if we want to go to Mars, especially in weight-bearing bones like the hips and muscle mass can drop like up to 20% without intense exercise. So we need to exercise really hard in the space. We've seen this in ISS astronauts whose bone loss mimics osteoporosis, but much faster than on Earth. So we also know space because there's unique issues like, for example, SANS. SANS stands for Space Flight Associated Near-Ocular Syndrome. That's a big issue if we want to came to Mars surface and not come back blind. So it's where fluid shifts in microgravity and pressure optic nerve and potentially causing permanent damage to it, and it can be really dangerous. The other thing, the main thing for it's my point of view is immune system that gets wonky. Space flight can suppress it and make it infections more likely or overactive, it risking autoimmune issues and stress from confinement in small spaces like tin can habitat. It's messes with mental health as well, and it's raising cortisol level, for example, and it can weaken immunity even more. If we're talking long-term cancer from radiation, fragile bones and muscle that don't fully recover, it's delayed health issues, and we trying to trace them when cosmonauts are ending their careers, and it's we're still unraveling like different types of diseases or conditions that can happen. So tackle this, we're testing some solutions, and my work involves analyzing astronaut health data to refine this protection and to ensure that we can keep people healthy for years on the moon and beyond the moon. So it's about making sure that space doesn't cut life shorts. We definitely don't want that. Someone is dreaming about that, and they don't mind to to pass early. But if we want to strive in space, we need to handle this.
So how can we mitigate these main risks? What can we do?
Mainly it's technology, it's protection, and it's new drugs. It's countermeasures like resistant exercise. It's about making the environment more feels like home. It's also about lightning conditions. Many things need to be taken into consideration, but the main thing is that we can address that for now. So in the previous era of space flight, the main thing was just to make it. And for now, for today, we want not just make it to the moon or to the Mars. We want to make it sustainable, our presence sustainable and cozy as it.
Yeah, we don't want just to go to the moon. We want to come back and then
Make it like
ever
regular
after.
flights between countries.
Yeah, I wonder when you watch sci-fi films, there is a switch. You just turn it on and you get the gravity like on Earth. Do we
Yeah.
have any research or technology that would allow to imitate the gravity, at least to mitigate, I think, half of these risks? Yeah, because of the muscle atrophy, probably. Yeah. I don't know, probably the bone density would also be less harmed. Yeah, if there is no so much microgravity involved.
The only thing that I can say on that is for now, only project that we have, maybe not we, that I have in mind is WASP. So it's a commercial station that will make artificial gravity. They claim that they can make artificial gravity like Earth-like, moon-like, and also Venus-like. It was my personal question to the team why they want to make Venus artificial gravity, because it's like on Earth basically. So why?
Because probably you
They
just
answer
claim it.
me, we just can't do it.
This is
Yeah,
marketing, this is
yeah, of
marketing.
course.
It's practically like on Earth, but it's like Venus. Yeah, this is what we can.
But the main issue is about rotation. They
Hmm.
have you have down one effect like gravity issues, but now we have rotating system, and of course people don't human body isn't handle this well in much cases. So it's a problem also with the view from inside the station to Earth, because it will be a so-called motion disease that we have right now in the space when your vestibular system is going crazy because it's don't have coordinates in the space to based on. And the main solution for that right now is just practice and make the habit out of this. So we just adjust to it with time. But if we have motion disease and on top of this it's a rotating system, it's even harder for our vestibular system. But I don't know, they don't much those questions. I think they will address this later.
Yeah, and before that, all the astronauts will be just around. Tough life.
Yeah, it is. Yeah, who don't want to go to space? I don't know. I will be the first person. Yes, I am. I will contribute.
Yes, and obviously you want more women to go to space, because early this year you also founded a Women's Space
Yeah,
Academy.
why
Yeah,
not?
with a goal to bring more female astronauts into space. So tell me a bit more about this initiative.
So, Women's Space Academy is my baby. Yeah, started it this year after my birthday, and I want to get more women into space stuff. It's like science, engineering, all of it. And we're building a community with mentorship, workshops, and stories of women rocking in the field. There is barely any research on women in space because science has always focused on the men, how drugs and are mostly tested on guys too. So it's a history thing that we need to adjust, not a capability thing. Only like 10% of astronauts are women because of old school biases and a few women in STEM back in the day. So it's not that women can't handle space. Some data even says that, some research said that women might do better on long trips or just in space itself, in space
Why?
environment. Evolutionary, and because our body adjusts its evolutionary builds to produce life, to be just more resistant. Yeah, so it's taken time to shift, and I hope that my initiative will speed up that thing. So at least it will inspire some girls to go into STEM and understand that it's the place for them to be and thrive in the space industry as well.
Do you think that there is actually any kind of sexism in space? Like as a woman in space industry, have you ever experienced this? Like space is not a profession for a woman.
Yeah, I have such experience. I don't know what to add to that. The person experience is of course unique. It's matter, of course, but in the end, we all just humans, and we need to address those questions from different perspective. I think the paradigm is shifting, and I really appreciated this. In Russia, for example, in scientific community, the difference is not so drastically different from the other world. So we have much more women in science than abroad, and that's really cool. But when we talk about working spaces, that's the place where it hits different, and it's the same as in all other parts of the world.
Yeah, and there was recently a story about like all female space.
Space flight.
Yeah, space flight. And from one side, many people praised it. From the other side, many people said that this is just a decoration and it has
Yeah.
nothing to do with a space flight, naturally.
Yeah, it always will be like that, I think, for next decade. I think it's definitely be not much anything else. Yeah, okay. we will handle it.
That's for sure. And to wrap it up, tell me how people can stay informed about all the amazing work that you are doing at LunCo with your Women Space Academy, how they can stay informed.
Let's start from the last thing that you say, that you mentioned about Women's Space Academy. Is mostly for Russian community, because in other parts of the world, you can find many activities on such questions. But in Russia, we don't have. Of course, we have, but it's not about how to increase the interest in space science, and how to increase interest into becoming a cosmonaut, a woman cosmonaut. So it's a main thing for me to increase the numbers of women cosmonauts, particularly because in States we have many women in astronautics, and in Russia we have just 5.
Валентина Терешкова.
Yeah, we just it's not so much. We have one acting cosmonaut, Anna Kikina, and one candidate for right now. She's a aerospace engineer that make engines, rocket engines. That's really cool. And that's all. How you can make science, how you can do research on women health in space when you have 1.5 cosmonaut. Yeah. Always mix this up. So for now, the main project, and I'm really excited about that, is that I'm COO, Chief Operation Officer at LunCo, and we making an open source platform to design lunar missions, and just lunar missions. Picture it like Roblox, or if you know Kerbal Space Program, but it's for space and it's for professionals and not for professionals as well. And it's with Web3 twists, and people will use our 3D tool, LunCo to create spacecrafts or lunar bases, and every design you can turn into NFT, and you can own it or sell it. And my job is keeping it all on track. And we want to tell lunar base by open source lunar base by 2042, built by people worldwide. And this is wild. This is really fun. To make something technical, that's it is, you need to still make it easy for everyone. And LunCo has real physics and 3D design, but not everyone's an engineer or not everyone in Web3. And adding on top of this all the mechanics with the blockchain, it's a really it's a big puzzle, and I'm really excited to solve this thing. So I will cover in the future my work, our work in LunCo. I will make more content in English, I think, because for now I'm in international project, and it's really valuable for me to stay in touch. You can follow me on X, on Twitter, on Instagram, basically everywhere. It's just handle is just my name, Rina Faber. So, but you definitely need to check out LunCo, and because it's LunCo,
LunCo.space.
because it's a future. I see it is a future of space exploration. We will accelerate our sustainable way to the presence on the moon and the Mars.
That sounds super exciting. Thank you so much, Rina. That was a very enlightening conversation. I'm sure that
Thank
our
you.
audience will enjoy it. Thanks a lot.
Thanks.
Bye-bye.
Bye.